All right, this video is going to be long, but it's long overdue. And so we need to show you how to set up the entire Talos stack of Omni with the image factory in Kubernetes in a completely air-gapped environment. We've had things like image cache for allowing you to create single Talos nodes in an air gap, but we've never done like the full stack. So let's walk through every component, how you're gonna like seed files into it so you can do upgrades. And we're also gonna do this with full TLS certificates, a custom CA internally. We're not relying on any external certificate chain or anything. We're gonna create our own CA, build up everything so everything has certificates, everything goes through TLS. We're going to do the entire thing in this video. So buckle up if this is what you're trying to do. Get ready. And we are going to do this manually. There are automated ways to do this, but we're going to show you every component so you understand how the pieces fit together, what the role of each component is, how they interact, and then hopefully you have a much better picture around what they're doing and how to do this yourself. To get started, I just want to show you conceptually what we're going to do here because it is confusing and I want to make sure that we're all on the same page here. So let's say that this is your air-gapped environment. This has no internet access inside this box. And so the things we need to do is obviously we want Omni. And that's the main component for all of the Kubernetes clusters to talk to. And so we're going to have, these are Talos nodes. They all live inside your air gap. This can be, if this is like multiple sites, I don't care how this is actually set up. That's just inside the air gap box. All of the nodes need to be able to talk to Omni because that's where Kubernetes gets upgraded, Talos gets upgraded, patches get applied. All of that stuff happens through Omni. The other components that Omni needs is it needs an image factory. Let's call it IF, which is what builds your Talos images for you. And it also needs a container registry. And so the container registry, where everything comes from, that's just Omni feeds from it, image factory feeds of it. So generally what happens is image factory is going to fetch stuff from the registry. Omni is going to ask the image factory for information. The nodes generally talk to Omni initially to get their config, and then they're going to fetch that directly through the registry. So they're fetching images down after Omni builds them. This cycle here of like image factory and registry, they go like image factory caches images in the registry. There's schematics. There's all this stuff that gets cached inside the registry, but that's where the main components are coming from. So what we need to do is we're going to have a laptop or some machine out here, an admin machine, which generally is just going to like seed this registry with information. This does need some level of internet access to be able to download from images. You could like theoretically build everything from scratch inside the air-gapped environments. You would need to just compile a bunch of stuff. And so in this case, we're just going to download the pre-compiled stuff, pull it down, send it to an image or to a registry, and then set up the other components. So that's generally the picture. That's what we're going to do. And we'll walk through every step one by one. And I have a home lab here on my desk. And this home lab is a separate router that has no internet access. My admin machine that I'm recording from has internet access and can talk to the other node that I have a computer that's on that router, and that router or that computer has no internet access. It is a fresh install of Rocky Linux. And so we're doing this like it would be a normal rel box inside of your environment. And we'll just walk through every step. So just to get started here, on the left is my admin machine that has internet access. That's where I'm going to download everything to. And on the right over here is my air gap machine. I'm SSH'd into it right now. I'm going to try to show you as much as possible to like, here's how to download everything on the air gap machine so that you could move files internally so that then we're never bridging the gap, right? We should never actually like say, I'm pulling directly from the internets and pushing it into the air gap. You can do that. But again, we're trying to do this as the hard mode as much as possible to say like, actually we need to download everything. We're going to move that and then we're going to upload it. So that's what we're going to do. You got to get started on the docs and you move over here to Omni. We have the self-hosted environment or guide here. And then there's the run Omni air gaps. This is going to have all of the steps that we're going to follow. And again, we're going to set up every component here. I even forgot to diagram. We'll have some authentication endpoints. If you have any of these things already, if you have an image registry, if you have authentication, if those are already inside your air gap environment, you don't need to run them. I'm doing the whole thing from scratch so you can see how it works. Okay, so let's get started. And I do recommend like read through the docs first, just so you understand them as well. Like don't just blindly say like, I'm just going to jump into it. Because yeah, it's just easier if you know what you're getting into. So we recently revamped these. I've rewritten these docs probably 3 times now. And so now I'm just showing you all the steps. I tried to make it as much copy pastable as possible. It's not 100%. There's still some things that you kind of have to make a decision on. But we're going to get through and show you exactly where that fits in. So, and this is going to assume that you have DHC at minimum DHCP, just to get IP addresses. Again, you could set up static IP addresses. I'm not for this guide. I won't have a central DNS that I'm going to manage. I'm just going to do it all with like static Etsy host file. So you'll see how that gets managed as well. This is generally the command line tools that you're going to need, and let's go ahead and download each one on my machine connected to the internet. All right, so now everything's downloaded here. I have these 5 binaries. CFSSL is a faster way to kind of create certificates. It just is a nice wrapper around OpenSSL. Again, if you have your own CA internally, you're gonna have to generate some certificates for the endpoints. But in general, like I'm just doing that from scratch here. Crane is a downloader or a general image registry tool. We're using it to download images and save them to tars and then push them into the registry. Talos Control, obviously, to control Talos, and YQ is like a YAML generator. We're doing that just because white spacing is sometimes difficult to copy and paste, and so YQ is going to make some of that stuff easier for us. These are the main endpoints you're going to need. We need, like I said, a registry, factory, authentication, and Omni. I'm using this .internal, which is like a dedicated for internal use only RFC and everything. So we're going to export all those because we'll use them in commands as we go through it. And the first thing we're going to do is generate the certificates. We need a root CA. And again, if you already have this, don't worry about it. This is just bare minimum of what we're going to need for this guide. All of these should be copy and pasteable. If there's any problems, let us know. On different OSs, you need to put the CA that you just generated in different places. So in my case, I need to put it here because I'm on Red Hat's. On Ubuntu, you have to put it in a different place. So there's like different commands to kind of update that. Both of my boxes, actually, the one that's not air gapped is Fedora, and then the one that is Rocky. So I need the same command for both. And so I now my computer trusts that CA. If I hit an endpoint with it, my machine's like, yeah, we're fine. It's in the root of trust. And that again, not always the case. Sometimes like Firefox has its own root trust store. So if you're using Firefox, you might get cert errors still. But generally my CLI tools should be pulling from that CA as a trusted point. Now let's make some endpoints for certificates. And this is using this is the JSON file, and then we're going to use let's do the wildcard here. This wildcard is going to again sign a certificate for those 4 endpoints we just did, and then 127.0.1, and also the like 1 IP address on the machine. So if I look at this, just to show you, oops, that's not what I want. Just to show you, let's go ahead and show you like my machine that's the public IP, or one of the IP addresses on my node. That's not the one I actually want to use. If I look at it again, actually let's do, in this case, I have multiple IP addresses, and the one I actually want to use, because this is the one that bridges the gap of where this is running, is here, but this isn't actually where I'm running this box, this isn't the machine I'm running all the endpoints on. And so I actually need this from my air gap machine. So let's go ahead, and we have all these tools here. Let's SCP them over. And now over here on my air gap machine, once it finishes, I'll see I have all those tools. I'm going to move the binaries into user bin so I don't have to like use them locally. So I'm going to do move CFSL, Crane, JSON, Talos Control, YQ, and I'm going to move those into user. So now I only have the CA. I am going to copy that CA into this root store as well, so it's trusted on this machine. And then I'm going to generate this, and that's the host name that I actually want, because if I do hostname I here, I only have one, and that's generally what we want. I can cat that wildcard, and I'll, oh look, I didn't export them. See, where'd it go? Here. Okay, now they're exported. Now I can create that wildcard, and now I have those endpoints. So my certificate will have all of those names on it. One quick step in between here, before we get too far, because I have no DNS, I do need to set up my Etsy host file with those endpoints as well. And for the machine I'm running it on, that's going to be 127.0.0.1. So let's go ahead and add those. I don't even have Vim on here. This is, I forgot. Sudo vi. Okay, now you can see my 127 has registry internal, factory, Omni, and auth. So anytime I try to go to any of those domains from this machine, it's going to redirect me to localhost. Now let me go to my air gap machine, because it's my admin machine. I need to do the same thing on my admin machine, but point it to the IP address of the air gap machine, because that's where the services are going to be running. And so here's those registry, all those endpoints are pointed to the 68144, which is my air gap machine. So from now, if I am on this machine and I ping auth.internal, it's pointed to the air gap machine. So I know I can reach it. Okay, we have our wildcard. Now we need the gen cert. So let's generate that real fast over here. And then we're going to cat these two, the server and the CA together, just to make a chain, just because some things are a little more finicky about having the full chain there. And so we're going to use this server chain pretty much everywhere. And also we're going to make it, again, in a production environment, don't do a wildcard for this. Make individual certs. We're making it 644 readable by everyone, because we're going to mount it in multiple containers. The same cert, we're not copying it, we're like mounting it. And some of those containers run as different users. So we want to make sure each user inside each container can still read the certs. Now we get to the image factory and container registry. This is just, again, so far we've just done certificates. Image factory and registry is a separate step. Those are the other two things that Omni needs to run. We need to go deploy image factory on-prem, and that gets us here, which is the second guide we're going to follow here. We're going to go back to the original one. We just need to go back. We need to deploy image factory first. All right, and in this case, it's asking us, a couple tools we need. We need Crane and Podman or Docker. We already have this registry endpoint exported. And we're going to go, there's three options here. A secure registry, which needs certificates that you run internally, an insecure registry, which is just YOLO, like let's just trust it, and an air gap registry, which will use the certificates that we generated, but also we need to do this like Docker download and Docker, or Docker save, Docker load. And to make this even harder on myself, this machine, this air gap machine, doesn't have Docker installed. I'm going to alias it just so the commands work. This machine does have Docker installed. So I'll be using Docker on one side and using Podman on the other. And one of them, actually, I think both of them might have SE Linux enabled. So for air gap, we're going to export the registry 2 image and the image factory image. And then we're going to transfer them and load them on the other machine. So let's get both of them over here. SCP registry tar, image factory tar, and then where's that command here? And then over on the other machine, we're going to do the load. So this is because I don't have internet access. I don't have a registry yet. I need to just push files to get a registry running. I need the base images available on this other machine. So once that loads, and this is just a, hopefully if you're doing anything air gap like this, you have some way of doing this. You know how to download images and push them somewhere. So we have that, and now we need the, we're going to run the registry with the server key, server chain, all of that sort of stuff available. So, and that's on the air gap machine. That's inside our network. I should have at this point a registry running with a certificate that I trust, because I just created the certificate. I just added it to the trust, and it should work with that trust. I don't know if I might need to restart the daemon later, but we'll get there. We're going to create a signing key, which is we need to sign all the images that we're going to be pushing into this cache. We're not going to worry about image cache storage right now because we don't have an S3 bucket or anything. And now we're going to run the image factory. Again, if you're connected to the internet, it's going to use the upstream Sidero Labs registry and just get everything it needs. It's a pretty easy command. You need a config file and a command. In this case, we're going to run it air gapped, which has a bunch more steps. There's a lot more problems because we have to generate a list of files we want to download, and then we need to move those. Okay, so now we need to download all of the images for Talos locally onto my admin machine so we can then push those into the internal registry. This command here is going to give us an images.txt for a version of Talos. You'll repeat this for any version of Talos that you're going to use. So in this case, I would say image.txt. If I wanted to append to that and just get more, let's do 12.4 as well. Images.txt, actually, well, that didn't append, that just overwrote. But if I cat that file, I'll see all of my images here, including, let's get that wider, including all these system extensions. And the system extensions, this is important here because these have a digest. The digest is part of the build where Talos only works against that digest of the image. Trust me when I say you want to download these with something like Crane that can repeat the same digest from an external registry to the internal registry. If you're trying to download these into like a tar file, or there's a bunch of tools that will download an image and then push it, that's not repeating the digest. The digest is going to be different internally, and you want to keep the digest the same because that is what is pinned in that Talos version. So in this case, some of these are tags, and if you're familiar with container images, tags are mutable. I can change the tag. The digest is not mutable. So I know for a fact that this one is going to have a specific layer, and all of these system extensions are multi-arch. They have the ARM and the x86 builds in them. So you can't like separate those out because again, the build in Image Factory is going to fail. The Image Factory requires the digest to be the same. So please trust me when I say follow the documentation. I promise you I've messed this up more than you have. And I've tried to do this a bunch of different ways without using a direct digest copy. So use Crane. We have inside of our tooling here, and again, if you're doing you have internet available, your admin machine can bridge your air-gapped environment, you can run this directly from upstream, push it internally. That'd be fine. If you need to move your admin machine to a place that does not have internet access, like switch networks, you're going to have to like download the files into a folder and then push them. We built tooling into Talos Control to let you do that. So in this case, we're going to download all of those containers with their images or with their layers, like in a folder. Everything's going to exist in a folder, and we'll download them all. I'm going to force because I had a folder already. This will take a little bit of time. Each build is approximately 4 gigs of data. And so you're going to be downloading all of the images, everything you need for Talos specifically. We're going to do Kubernetes stuff later, but this one is I need all of the images and extensions for Talos to work. So download this, let it run, and then we'll publish like a temporary registry. We'll show you in a second. I do want to point out here that you don't need to download every system extension. So if I go into my images.txt, let's see I never want to run NVIDIA stuff. I can, NVIDIA is some of the largest system extensions. I could just delete all these lines. I won't download them. They would still show up in the image factory because the image factory is using a extensions container that will still have them listed. Those builds would just fail. And so in that case, you could save some space here in downloads if you want to, but if you have, a few gigs for every build, you can just do that. It'd be fine. So now let's go back over to the docs, and these are the commands to run a temporary serve a registry that serves that directory structure as sort of a container registry. It's not a full container registry. All it's literally doing is serving the layers over HTTP. We are going to get a certificates. We're going to create a cert just so that we have a TLS endpoints. But I do need to get the IP address for my machine, and the machine I'm on actually has 2 IP addresses. So this command would not work out of the box for me just because I have multiple IP addresses. If I go host name, I don't necessarily, I could use any of these because I'm going to be pull localhost. This is the one that's on my air gap, so I'm going to use that. So I'm going to export IP equals this IP address. Now we're going to generate a certificate based on that IP address. And that's just creating 2 self-signed certs locally for me. And then I'm going to publish this image cache on my local IP, port 5000, with that folder and the cert and the key, and then I'm just going to run it in the background here. It is going to spit out logs for me on the access, which will get annoying, but I'm going to kill it here in a second after I actually push the images. So now I need to use Crane and push from the source. I'm going to look at every line in that text file, every extension that I downloaded. That's my source image, and I'm saying that is published on my IP at 5000, and then I'm pushing it to that registry endpoint, which is the other internal registry. We are putting insecure here, not because there's no TLS, but because the certificate's not trusted by Crane. I didn't put the TLS root in my cert store. So it's insecure in that it doesn't trust the cert, but it's still using a TLS endpoint. So we are going to push that. If I also follow my registry over here, I could do podman logs registry, and then we will see, as this goes, we will see those images being pushed. And that's just going to push them again locally from my local registry over there. A lot of these already existed because I have run this before, but that would give you all of the images inside your registry, and now Image Factory should work. Once that is done, we are going to sign the container images. We need to generate a key pair first. We're going to use cosign. This is for offline signing verification. You can run this on your connected machine or the air gap machine. You would just need to export and import this cosign image. I'm not going to bother. I'm going to do it over here because all it really does is spits out a cosign file, a cosign key, cosign pub. So I can transfer just that portion and then move it over. So SCP cosign, there, we'll send just that. And now over on the air gap machine, we can say which file we're going to use. We need to set an empty password because we're automating the signing. And this again uses that images.txt file, and it's going to go through every image there, and it's going to start signing it. You do need to mount in the certificate CA because it doesn't trust it necessarily. Oh, you know what? I do need that cosign image here. So I do need to download it. Again, I could do this from the connected machine, and because it can talk to the registry right now, but I'm just going to do a Docker save. What's the save? Oh, registry, this was. Tar. Copy that over. Over here is Docker load. Was it that's it. Docker load cosine tar. Bring that blob in. So I'm going to do that now. And I'm making sure I have registry endpoint sets, and I can't have the key file set, so we should be good. Error signing, what was it? Permission denied for which part? It's gonna go through the whole thing. So I got permission denied there. Cosine key is not readable from the user inside of the container. So we're going to chmod 644 key. That should solve that problem. Oh, it does have user ID G. Oh, you know, because this is Podman, it probably has user namespaces set. That's my guess. Let's see if this one works. And then we also say don't upload, because again, this machine's air gapped. We have no. Usually, it would send the log for signing. Error again. Permission denied on that cosine key once again. This might be, but I have Z for permissions. Let's see. Mount my current working directory. Oh, I don't have ROZ on that. I'll fix that in the docs. Okay, watch this. What I often do, I have a scratch pad. What I need here is ROZ. There we go. That should do it. Because I didn't have because this has system SE Linux enforcing mode on, I don't have permissions with those labels. Let's see if this works. SE Linux label of home Jaguar. Oh, you know what? I probably need to mount the file. I just need the file in there. Because I'm trying to mount my whole directory. You can't do that. What's the key? Cosine key. Key file, right? Yeah, cosine key. Okay. Easy fix. I just realized that I didn't label that, or I didn't set the read only and the systemd label on that. So let's see. This should work. There we go. Now we're pushing to the registry. So we're signing it. We're looking at the image. We're signing it, and we're pushing it back to the registry. And that gets us all of the signed images in the registry that the image factory needs. So the next step is running the image factory. We already have this set from before. So we need to set a config file here. And this is with a self-signed CA. If you're doing it insecure, you have a different config that just says insecure for all the endpoints. But we will be mounting that in. So let's copy that. We're still signing. This is just making the config file. And then down here, we should be able to run that config. So got our config. Port mappings are disabled. I'm using host here because I'm running the registry on the same server. If these are different servers, you don't need nethost. But because the registry is on the same server, if you have two containers that don't have host, then it won't be able to see the other ports unless you do the Docker like bridging between them. So I'm just doing host. It failed. Shoot. Okay, so I'm going to and we'll run it one more time. Let's see, logs. Hey, it looks like it's running this time. Yes, we have the image factory. Okay. Okay, so if you got to this point of running the image factory, you should, from your admin machine, if you set up DNS, I should be able to go to, not registry, image factory 8080, I think, is where it's, one thing that I forgot here. This server, so let's see, wait. Ping. What's it called? Factory.internal. That's what it is. But something I did forget here is by default, this Fedora box has firewalls. So I'm going to have to open up ports 8080, which is where it's running. So if I look at, it's running as host, so it's not showing me the ports here, but I need to set the firewall rule to allow it. First, I don't have any extra ports here allowed. So we're going to do firewall CMD add port 8080. Again, it depends on your distro. I can make that a little bigger for you. Sorry. Success. So now if I list all, I'll see I have 8080 here. Let's go on to our factory.internal and then just validate that we can build an image now. I should see the version that I just pushed in there on 12.4. And I'm just going to pick any system extension just to make sure that it builds. Again, these are pulling from those system extensions. I'm going to leave everything default here. And you should see your factory internal here as a URL. And now it should build and give me an ISO. This is just a good sanity check. Did this work? Yes or no? Because after this, we want to point Omni to this, which is going to do the same thing. So there we go. We are getting our image that was built and has a system extension inside. So let's go back to the Omni air gap documentation. We already went through our root CA. We now have a working image factory. Now we need to set up authentication. Authentication is the other piece of this puzzle to allow us to authenticate through Omni. Omni doesn't have any built-in authentication. So we're pulling in Dex. Dex is just a super minimal OIDC. It can be a connector for upstream endpoints, or it can just be static auth for your environments itself. Hopefully you have some more official authentication, and we're just, again, using Dex as an example. You can still leave it and have it bridge the gap, or you can remove it and use something else. This is what we actually want. We want to do the save command. And then SCP it, load it, and push it. I could push this into the local registry and pull it from that, but it's also, I can just put it in the cache. We're going to run it. Here's the registry. If you want to push it and store it into that, we need to create a user password. So we're going to export this. I got to do this from my internet connected machine because this air gap machine doesn't have HD password installed. So I need to do that. I'm going to call this, and that's just going to give me what? It didn't print it. Oh. That's giving me a hashed password that I'm going to use. It goes in this config. We have our auth endpoint, which is auth.internal certificate chain that we had from before. Here's our secrets. I think this is just called, it's like a shared secret. And then here's that password we just generated. Oh, don't ask the system. No. So I'm going to generate the YAML file over here, which has those variables in it. I get my auth internal endpoint, and then I'm going to SCP that over. And now I can run Dex mounting that in. It looks like I don't have the RO and Z on here, so I gotta add those. So let's bring this in here. And then on all of these files, we need to : RO : Z. and that's giving me the read-only permissions and SC Linux labeling. On this machine, I should have that dex file here, dex YAML. Now let's run it. Oh, I don't actually need to do it from registry endpoint in this case. Actually, let's just push it. What was our, we had a load. What image was it? This. So we will do that previous command here, which was docker. We have to tag it though. I need to tag it here. Yeah. This is it. There we go. Now we pushed it. Now we can run it. And now we have three things running. We have Dex, we have image factory, we have registry. And Dex is just, again, serving that static password that I just set. That actually I don't even remember. Oh, jeez. We'll figure it out. And now we get to run Omni. Omni requires all of these endpoints to exist in your network, or something of that, like, not have to be those host names, but an endpoint for each of those things. You need an auth endpoint, you need the image factory, you need a registry. Let's generate our keys for etcd encryption. Okay, there we go. And then let's export. Now we should have an Omni ASC, which is our encryption key for etcd. Same thing as before, we need to download and upload our Omni. Let's do it over here. Oh, let's see. I want a Docker. Where's save? Oh, you know what? I did that wrong. Look at that. It's pulling not from there. So update that command. Let's do it over here, but this is going to be GHCR. Save it out. SCP omnitar. Load the inputs omni.tar tar a. We will also relabel it or re-tag it here after we load it, just so we can also push it locally. Okay, now we have Omni on this box and also in the registry, and now we get to start it. There is a new config file for Omni here. We're not using it for this example. We'll update the docs later in the future, but you'll have a similar sort of workflow to Image Factory where you create a YAML file and then run Omni, because all these flags get way too messy. We change a couple things in here, like the metrics bind address, just because we assume you're running this on one machine. They both, the Image Factory and Omni, expose the same metrics endpoint. And again, you have to have like all these variables set for your auth endpoints, all that kind of stuff. So we are copying that. And there are some things that are like hard coded for that Dex secret here. Those things that, again, you can change and should change in the future for a production install. And we're also still running this with hosts because of the because everything's running on the same machine. So that's factory.internal should just work. I didn't make a directory. Oh, and you know what? I have to volume out these with the same Z. So we will do that real fast. This one I do need not only read only. So I'll do RW. So let's make that. It wasn't out, right? No, yeah. I also need a SQLite. And that should be read write as well. Yep, read write. Oh, I can't bind to 443 because I'm not sudo. So in this case, I do need to run this one with sudo because the standard user can't bind 443. And Docker's not found because sudo doesn't have Docker. Okay, let's see if that works. There we go. Well, that's weird. I think it just cut off there. I won't see it here. I do see it there. Sudo and okay, so after running it with sudo, we should have Omni running now. And again, this is from my non-air gap machine, omni.internal. And it should be on 443. So we're going to go HTTPS. Oh. Got to open that firewall. Firewall commands. We got to allow 443. Success. There we go. Advanced. Auth internal 5. I can't hit auth internal. 5556 is not allowed. So we also need to do that. 5556. Omni.internal. Authenticate UI access. Bounces me out over to auth. Grabs that. Now I need my email address from that config. Dex dot, what was the admin dot at omni internal, and I think that was it. Yes, grant access. Sweet, we're in. Woo! Completely air gapped. Okay, we need to do one more thing. All of this is running with CAs that no one else in the world trusts. That includes Talos. So our Talos nodes need to trust this CA for Omni to be able to run and connect to it. Okay, now we are on to the final step. We are going to create a Kubernetes cluster. And to do that, we are going to create the same thing we did with the Talos images. We're going to download the Kubernetes images that we need so that we can push them into the registry internally. So it's the exact same process. I'm saving these into a different kates.images text that you can see here. Again, you can change these images. You can pull them from somewhere else. We're just pulling in these from upstream so we can mirror them internally. And again, if you're connected to an upstream source, you can just download them. If you need to do it air gapped, you can do the same thing we did before. Download them, run the registry, and then push them with Crane. I'm gonna cheat here because I do have internet access, and I'm just gonna push them directly. because we already did the air gapped, or the completely download air gap mode, and I'm just going to push these in so it's faster. I actually think most of these already exist because, again, I've already been doing this. Now we're going to create the installation media, and we're going to do that with the tool called Imager. Imager is going to like create the bundle for us. Omni is still going to be used in the future for doing upgrades, but for the initial install, we want to embed the CA certificates so that it's trusted. And you can do this through Omni as well with patches. I'm just showing you the kind of manual CLI way to do it. So this is going to create a patch for a trusted root config using that ca.pem that we had from before. So I'm just spitting that out, and if you look into trusted root config, this is just a standard Talos patch. And I'm going to do this with Talos 112 or above, which has the ability to embed these configs directly in the installation media. So we're going to move it into this out directory and rename it machine config just for convenience. So I have the same file in that out directory. I do need to attach one thing to it, and that's going to be our join token for Omni control. You can get this directly from Omni if I download machine join config here. And I'm just going to open that, and you'll see this is what we get from it. The only thing you're going to need to do is change this. If you don't have global DNS that would resolve this omni.internal, you have to change this to the IP address of Omni. So in this case, it's 192.168.8.144, I think is the machine. Everything else we're leaving the same. I'm actually going to do it this other way, because I do want to show you I can do this from Omni control directly. So I can get Omni control, the binary right here. I can get my Omni config, which lets me talk to this Omni instance. So I'm going to move my downloads Omni config into .talos omni, and I'm going to call this air gap YAML, and then I'm going to export omni config equals that file. So now if I try to do like omni control get clusters, I'll be talking to my internal Omni, and I need to authenticate. Did it automatically open the browser? Let's see. Probably opened the wrong browser. There we go. What is this? Admin dot internal. And again, you should have some sort of SSO properly set up. This is using DEX that we set up earlier. We're going to grant that access for the CLI. And back over here, I should have nothing. I don't have any clusters available. But my next command should work properly. In here, we're going to get the join. Let's print it first. This just prints the exact same thing we downloaded from the UI. It just makes it easier for us to grab it. So we are going to append that to that same machine config YAML. And I'm going to edit it so that I get the IP address in here. Because again, I don't have DNS. Or I don't have a global DNS at least. So that'll let my machine off this installation media find Omni properly. And now we need to build our installation media. I just realized that I have the old variable for Talos, so I'm going to update that here. And all this is doing is it's actually pulling from my internal registry, which I don't necessarily need to do, but I can do if I'm internal. And it's embedding that config. It's saying, hey, by the way, put this in the ISO. Oh, I don't have the cert trusted on this machine, so I'm just going to go ahead and pull this from upstream. I don't feel like updating my local cert. You could also say insecure, but I'll just do that. This doesn't work on SE Linux when SE Linux is enabled, so just be aware of that. And now in my out folder, I should have this metal.iso. Let's grab a USB drive, plug it in. I'm literally plugging in a USB drive. I have a machine here sitting next to me that we're going to boot this from. So now we need to DD it on that metal ISO onto my dev SDA. Actually, let me just double check. I think that's the right dev SDA. Yeah, this is my partition there, or my USB drive. So we are going to DD that onto the USB drive. And once it writes, I'm going to eject it here from my computer, pull it out, and plug it in. I am going to record this from my phone just so you believe me that this all boots. Let's go back into Omni as well. Machine boots up, gets network, and shows up here as connected. So I now have all my information. I'm going to unplug my USB drive. That goes away here, and we should be able to make a cluster. Okay, we have our machine connected. It's up and running, available to us in the system. Now we need to make a cluster out of it. We're going to create a patch for this first, and just remember, we're going to call this air gap patch. We're going to be setting our registry endpoints, our time sync disabled, and also embedding that CA all as patches in here. So we can cat air gap patch. You can see here, this is getting those endpoints. So we'll get a mirror for where we're running our registry. Time sync's gonna be off, and we have our certificates for the registry as well, so that we can actually fetch images from that. We need to trust it because that registry is running with this CA. So we're going to trust that as an endpoint here. And then we are going to fetch one of the machines. So if I like Omni control get our cluster, or Omni control get machines, we can see the machine here. You'll need obviously Omni control setup for this to work. And I'm just saving this as a variable so that I can then use it here in a cluster template. Cluster template is going to be the easiest way for us to make sure we do this properly. And this is going to set this cluster template to have a version that we have in our registry, 135.0, the version of Talos that we have in the registry as well, and then sets that patch as the patch file for it. So if I look at that cluster template, all it's doing here is really rendering out that UUID that we had from before. So we should be able to apply that. And again, if I go back and look at my Omni, I don't have any clusters right now. So let's sync that cluster with that patches, and we will try to do this as fast as possible to where to go. Go back and watch it. It goes too fast. I can never catch it in time. There it goes, and we automatically, the machine next to me starts pulling. We will get it. It's actually already rebooting. It already did an install. It turns out this goes really fast when everything is local on your network. The images are fairly small. It rebooted, it formatted that drive, it fetched it from the registry, and in just a couple seconds here, we should actually see it reboot fully and be in a healthy waiting state. And that's it. That is the entire setup from nothing on a machine all the way up to we built a cluster and we trust that cluster to run workloads in an air-gapped environment. So feel free, give it a try. We do have an easier way of doing this. If you want to do this on a Kubernetes cluster, it can't be a cluster that Omni's running or controlling, but it can be on a single node Talos instance. So we have other documentation. There's a simpler video for that. I just wanted to walk through every step to show you exactly step by step where the certificates go, how we're going to generate them, each command that we're using to run them, so that you can understand what the process is, especially if you have to run this on a different operating system, a known operating system in your environment. So that is the entire video. Thank you for watching, and we'll talk to you again soon.